Imagine standing at the edge of the unknown, staring into the golden haze of a distant world nearly 1 billion miles from Earth. On January 14, 2005, humankind achieved something extraordinary. The Huygens probe, built by the European Space Agency, touched down on Titan, Saturn's largest moon and one of the most mysterious bodies in our solar system. For more than 2 hours, this small craft parachuted through a dense orange sky thicker than Earth's own, braving winds, icy temperatures, and clouds of methane. Unlike our moon, Titan is cloaked in a substantial atmosphere, and unlike any other known world besides Earth, it hosts vast lakes and rivers on its surface. Scientists had dreamed for decades of unraveling Titan's secrets, yet little was known before this descent. The Voyager 1 flyby in 1980 offered a tantalizing glimpse, suggesting Titan might resemble a frozen version of our own planet. But what the probe uncovered as it drifted down through that alien twilight would transform our understanding of what another Earth could truly mean. As the probe pierced Titan's atmosphere, its protective heat shield flared with friction before falling away. One parachute, then another, deployed in sequence, slowing its fall to a gentle drift. Suspended in silence, Huygens opened its scientific eyes, snapping images from nearly 150 kilometers above Titan's surface. It tasted the air, measured electrical activity, and recorded data that scientists had only speculated about for decades. Methane and nitrogen filled its sensors, confirming theories that Titan's skies echoed the chemistry of ancient Earth. Temperatures plummeted far below freezing, yet the structure of the atmosphere revealed layers as complex as Earth's own. In those fleeting minutes, Huygens became a messenger from a different epoch, showing us what our world might have looked like nearly 4 billion years ago. Every byte of information it sent back to the Cassini orbiter circling above was a treasure, clues to a story older and grander than anything Earth alone could tell. Then, after more than 2 hours of descent, the probe touched Titan's surface. Unlike the high-stakes landings on the Moon or Mars, planned with years of orbital reconnaissance, Titan's landing site had been chosen in near darkness. Nobody knew if Huygens would crash into a sea, strike jagged rocks, or be swallowed by dunes of hydrocarbon sand. But instead of disaster, the probe settled gently onto a flat plain. Its cameras revealed a strange yet familiar landscape. Pebbles rounded as if by flowing streams, a surface textured like wet sand, and an eerie twilight glow filtering through the haze above. Although no liquid was visible at the landing site, the terrain resembled an ancient floodplain, hinting at rivers that once surged across the land. For 72 minutes after touchdown, Huygens transmitted over 100 images before its batteries finally died, leaving humanity with the first and only photographs taken from the surface of Titan. What those images revealed was astonishing. Networks of river channels cut across Titan's face, branching like veins and merging into vast deltas, eerily similar to the drainage systems on Earth. Bright highlands gave way to low, flat regions, suggesting erosion by rainfall or something like it. Scientists soon realized the rainfall was liquid methane falling from clouds high in Titan's atmosphere, carving valleys and filling lakes with hydrocarbons instead of water. Some channels appeared carved by gentler flows, perhaps fed from underground springs rather than storms. To see landscapes shaped by familiar processes, yet built from entirely alien materials, was like peering into a mirror but reflected Earth's geology through a dark, otherworldly lens. Titan was not just a frozen moon, it was a dynamic world, alive with cycles of rain and erosion, wind and flow, echoing the forces that had shaped Earth itself. Though Huygens' life was short, its impact was monumental. For the first time, humanity had touched a world in the outer solar system. It was as if the probe had extended our senses across space and time, letting us stand briefly on Titan's soil. Yet, the mission also left haunting questions unanswered. Could Titan's subsurface ocean, hidden beneath its icy crust, harbor conditions for life? Could organic molecules on its surface hint at chemistry that mirrors the dawn of life on Earth? Scientists now believe Titan may be one of the best places beyond Earth to search for the building blocks of biology. Its atmosphere is thick and protective. Its surface is sculpted by active weather, And deep below, there may be a warm, salty ocean waiting to be explored. Titan, in its alien beauty, might be the closest natural laboratory we have for studying the origins of life. That is why the next mission excites scientists like never before. A nuclear-powered flying rover named Dragonfly is being prepared to launch in the mid-2020s, with its arrival at Titan planned for the 2030s. Unlike any drone we use on Earth, Dragonfly will be the size of a small car, capable of soaring over dunes, rivers, and impact craters. Its mission is bold: to travel over 100 miles across Titan's surface, exploring multiple sites for evidence of habitability. It will study chemistry, search for organic compounds, and attempt to unlock whether Titan has ever hosted, or could still host, life. Imagine the day when we see new images, not just of one spot, but of Titan's diverse terrains. That moment will mark the continuation of a journey that Huygens began, humanity's first steps into a world that mirrors our own in strange, haunting ways. Until then, we can only look back at that historic landing and forward to what lies ahead. Don't forget to subscribe, because the story of Titan is far from over.